Hello everyone, welcome to the course on Object-Oriented Programming through Java. My name is Vivek. I am working as Assistant Professor in the Department of Computer Science and Engineering, Mlritm, Dundigal. So, in today, we are going to learn about string handling in Java. What are strings and how they are handled in Java. So it starts with a simple line of text, that is, in many programming languages, a string is treated as a simple array of characters. In Java, however, it is different. Every string is an object. Okay, so string, if we in other programming languages like C, C++, etc., that was considered as a continuous sequence of characters. Whereas here, everything is an object. String is an object in Java. This is a Java object. So you can see here system.out.println. This is a Java object we have given. So it is treated as a object. Okay. So strings are objects, not the primitive types like int, char, float, etc. So they are like this. A symbol holds a single and simple value. But whereas in our string, as you can see in the diagram, it is a more complex entity that contains data, the characters and capabilities, which are also called as methods. Okay, so here is a string that is going to store hello. Okay, so in that you can see here every word is having a separate unique identity, and in this we can find out the length of the characters present in the string, we can find the index of it, and we can even split the string. All these things are possible only because string is considered as an object, not a primitive data type or not a continuous sequence of characters, simple or like that. Okay, string is considered as an object. So how do we create this string object? So there are two ways, the explicit way and the shorthand way. Let us see both the methods. So this is a standard object installation. We know that we are having an operator called new operator in Java that is used to create the new objects. So we can create even strings also in the same way like other objects we create in Java using new operator. So string, my string is equal to new string, and in that we have given keep on coding as a text. So this keep on coding is considered as a string object string with the content as keep on coding. And the second way is shorthand method is string my string2 is equal to keep on coding. Okay, so here we are not using the new operator. Here what we are doing, we are assigning the string to my string2 using the assignment operator is equal to. Okay, so the syntax is consistent with how you create an object in Java using the new keyword, and here because the strings are used so frequently, Java provides a simpler syntax. It can look as a primitive assignment, but it can still create a string object. So this is how you create a new object using new, and this is how you create a new string, something like int x is equal to 10. This is how we have assigned a primitive integer x a value of 10. In the same way, we can assign a value to string called string my string2 using the is equal to assignment operators. So these are the two ways in which we can create a string. So what does the strings are, what is that it is going to make strings in Java special? Okay, so let us see. We are having the string utility toolkit, that is, since strings are objects, they come equipped with a powerful set of built-in methods to manipulate the strings or to do whatever we have to do on an object. We are having some inbuilt predefined methods. So let us see one by one what they are. So the critical distinction is comparing for identity versus equality. As we all know, string is a collection of characters. So there is a major difference between identity and equality. Okay, identity means both are similar. Okay, equality means both hold the similar value. So let us see what the primary difference we are going to get in these two things. Okay, so identity operator, as we know, that is our double equal to operator. Okay, so here using the double equal to means if we are saying something called x double equal to y, what does you mean by that? We are saying that the value that is pointed by x is equal to the value pointed by y. That means they point to the same thing in a same address location. So that is the reason why are those two variables pointing to the exact same object in the memory. That is not possible because every string is a new object. Okay, every string is a unique object. So that is why S1 equal to S2 is a false one. Okay, s1 is equal to new string, the value is test, here the value is test, but both are not same objects. This is object s1 and this is object s2, which are completely different. Okay, so that cannot be double equal to, that is not valid in strings. Whereas for the comparison purpose, we are having a method called equals. Okay, in the sequence of characters inside the two objects are identical. Here, if we use the equals method, we are not just comparing the strings, we are comparing the content within the string. So there we can see whether the content is equal or not. So here s1 is equal to s2 because the content is the same. Okay, s1 equal to s2 is true, whereas s1 double equal to s2 is false. So this is the major difference while we are using identity and equality. Okay, so this is one of the important thing we have to understand using strings is that double equal to is a false, whereas when you want to compare and see whether they are equal, we are using to use the equals method. Right. So what are the core tools for inspecting the strings? You want to compare or do any other methods, there are some core tools. For example, we are having dot length. So what does the length of a string means? Length of a string means the length of the number of characters present in the string. Okay, so we are get the number of characters in the string. So keep on coding is there, s dot length. If you count them, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so you might be having the 12 alphabets, but 2 blank spaces are also considered as components of the string, characters of the string. So that is why, although we are having 12 alphabets in keep on coding, we are having 14 is the length of the string. That is thing we have to keep in mind. Okay, so next, charAt int index. So this is one of the important thing. Here we are going to get the character present in the string. So here we are having keep on coding. So char c is equal to s dot charAt 0. That means, as we all know, it is a sequence of characters we are present in the string, and the sequence of characters, the best possible way to store is using an array. Okay, so in the array, indexing starts from 0 1 2 3 4. So when you are writing this keep on coding, so keep on coding, so it is going to store in the form of array. So this array, here we are having 0 1 2 3 4 5 6 7 8 9 10 11 12 and 13. Okay, so these are the array indexes. So when we say charAt 0, we are going to get k. When we say charAt 5, we are going to get o. CharAt some 9, we are going to get again another o. Okay, so this is how charAt works. Next, we are having index of char of c. So in this is the vice versa method. Okay, here using index we are finding the character, and here using the character we are going to find the index. Okay, so here if you can see, we have another doubt you can get here. So in this keep on coding, there are two o's. Okay, so how we are going to find the character? So when you are giving position is equal to s dot index of o, when you are finding an o, it automatically goes to the first location of the first o. So here we are having in the 5th position, this one. Okay, so that is selected first. So we are going to get index as 5. So these are some important methods that are present in the string. Next, a tool for deconstruction, which is obviously a split. That means since we are having a continuous sequence of characters assembled in a string, we can also split those continuous sequence using the split method. Okay, the split method is incredibly useful by breaking the string onto an array of substrings based on given delimiter. So you can create substrings from the given string. From a lengthy string, you can create the substrings using the split method. So we are having this keep on coding as our continuous string. Here we can give the index, and we can this is called as delimiter. Using the delimiter, you can create as many substrings as you can. Here we have created 3 substrings. So how we are doing, let us see here. So our string phrase is keep on coding. Okay, now split the string every time on a space is found. So I am splitting the string using spaces. That means I am going to find the meaningful words in my sentence. Okay, so string words is equal to phrase dot split, and in the double quotes I am giving blank space. Okay, so here string of words. See the representation here. String is representation as an array, square brackets. Okay, and then word is words. So we are creating another object called words. Okay, and what does the object contains? That object contains the phrase dot split. What is phrase? Phrase is our keep on coding. So that is being split. So how we are splitting that? Every time we are encountering a space. Okay, empty space. So the result is an array of strings, that is word of 0, which contains keep on and coding. So I am going to get word of 0, words of 1 and words of 2. So this is how we are going to split the string. So the read-only toolkit. So this is also one of the important thing why we are calling it as only read-only toolkit. Okay, all the methods return a new string object containing the result. So whenever you use a method on a string, okay, either to check or to add some methods, or you delete something, or you find out the index, or whatever be the method you are going to use, okay, every method is going to create a new string so that original string stays the same, which is called, that is why the property is called strings are immutable, they cannot be changed. That means if you are making an alteration to a string, that results in creation of a new object than modifying the existing object. Okay, so here we are going different methods for inspection, extraction and transformation. Inspection, just checking. Extraction, getting something from the given string like substrings or words or characters. And transformation, we are completely changing string from one form to another form. All these three kinds of methods are possible using string, but the only difference is that these three are possible and they are going to create only new objects. The original string object which we have created once is not going to change, which is immutable. So inspecting and comparing, for example, let us see what we are having. Equals ignore case, string str, case insensitive, equality check. That means you are containing two strings that contains red. A red is one string, let us say s1, and s2 contains some red. So when you use this method, it is saying that equals ignore case. So we are ignoring the case. That means we are either converting both into uppercase and both into lowercase and comparing them. So we are going to get the results. Here we can get s1 equals s2. Okay, next starts with and ends with. We can check for the prefixes and suffixes for a given string. Let us say we are having some 200 to 300 characters in the given string. In that we want to check the prefixes and suffixes, then we can use this method, starts with and ends with. Obviously starts with is called prefix and ends with is called suffix. I think you are familiar with the basic English nomenclature, right? Now compare to string. For dictionary order sorting, returns less than 0, 0 or greater than 0. So this is your compare to operator. Okay, so for dictionary order sorting. So what is dictionary order sorting? Obviously alphabetical order. Okay, in that we are going to get either less than 0, 0 or greater than 0. Next we are having extraction and searching. So what is this extraction and searching? So how we are going to extract something and search within the string, those are your extraction and searching methods. In that we have charAt, int, index. So charAt is going to give you the character, and index, since it is a number, we are declaring it with int. Okay, we have seen in the before slide, we have seen the example, this one. Okay, charAt, int, index, we are having that. Next we are having a substring, int start and int end. So we can create a substring. Int start is going to give you the starting character, and int end is going to give you the index of the finishing character. We are getting both the indexes here. Okay, so we can extract any exact portion of a substring at any point of time in any given string using this substring method. Next, index of string str, we can get the total index of that, last index of string str, first and last occurrence of a substring. So we can create a string and we can find out when it is in the first and when it is in the last. Okay, we can find the first and last occurrence of the substring using these methods. And the next one is transforming, creating a modified copy of a given string. So as you can see here, we are having the replace, char old, char new. Replace all occurrences of a character. Okay, so we can select a character from the given string and we can replace that character with another character, and we are going to get the modified string, obviously, which is also another object, not the original one. To lowercase to uppercase, as the name itself suggests, we can convert everything into either lowercase or uppercase. So trim, remove leading and trailing white spacing. Okay, so what is this trim? Remove leading and trailing white space. As we have the previous example, we are having keep on coding. We have given two spaces here, right? After on and before on. So when you use the trim method, what happens? This becomes a single line without any spaces. Keep on coding, it will be. Okay, so this is your trim methods, and these things are majorly used in information extraction, information retrieval systems to find out the answer to a given query. In natural language processing and information retrieval systems, these methods play a crucial role. Okay, to lowercase or to uppercase, as you are well available, if you take a real-time example of this, when you log into your email, okay, so you'll be having two prompts, one for email and one for the password. So when you enter an email, if you observe, you can see that you can enter your email in the lowercase or in the uppercase, it is not going to matter, whereas password is case sensitive, but your email ID is not. Okay, you can provide your email ID either in small case or in uppercase, because when they were validating the string, they were going to convert it into a single form and they are going to check the content but not the case. Okay, so for such applications we can use these things. Okay, so we are having a lot number of advantages of strings, because in the first program itself I told you the public static void main method is going to take everything as string arguments. So strings plays a very crucial role in Java programming. So the core truths of Java string. So what are the core truths of this Java strings? Okay, so first one, it is an object, that is to be cleared. Okay, in Java, string is not just a collection of characters. It is a collection of characters in the form of an object, which is immutable. Okay, it is immutable. That means it cannot be changed. Whatever that what we can say, the modifications you try to make or you make to the string, they are creating new strings but not manipulating the original string. Okay, and it has a toolkit. Obviously, we are having different methods through which we can work on the object as well as the contents of the string object. So string is a powerful construct with both data and built-in capabilities, not just a simple sequence of characters. Comes with rich library of methods like equals, dot length, dot split, etc. for effective inspection and manipulation. Obviously, safe also. Okay. Next, once created, a string's value cannot be altered. All modifications result in the creation of new string object. Okay, so these are the three core truths of Java string. So I will reiterate once again, in Java, unlike other programming languages, in Java, string is an object. That is the first point. Second point, it is going to have its own built-in methods to act upon the object as well as the contents of the string object. And third one, and the most important one, is the string object is immutable. That means once you create a string with certain characters, it is not going to change. All the modifications and ramifications you make to that, they are just going to create new string objects. Okay, this is clear. Now let us go deep into this concept called the immutability. Okay, so what makes it different from other programming languages is the string considered as an object and which is also an immutable object. So let's dig deeper into this immutable concept. The immutable core. Okay, so we have seen how to create and use strings, but what happens when we try to change one? The answer is the most important secret of all. Let us see, this is a string object that contains the string hello. So how it is immutable and what is happening to that? Let us see. So the immutable rule, a string's value can never be changed. Okay, when it seems like you are modifying a string, Java is actually creating a brand new string object behind the since. You might think that is the same string. Okay, let us say you have created some string str is equal to some abc you have created. Okay, so that, let us say afterwards you have added something like some def. Okay, okay, you might have added def. You think that the same str is your now abc and def. Okay, but actually this is another object, not the original string which you have created. Okay, so when it seems like okay that we have finished initial state, so let us say str, we are having a string object with content of coding. Okay, string str is equal to coding. Now you have modified str is equal to coding with sam. So what's happening here? So we are thinking that is the same str, but actually this is the new string object, not the old one. Okay, next, so that is going to this coding is going into the garbage collection. The old object is going into the garbage collection, and this str is having a brand new object. The name is the same, but the object is changed. So once again, look at the clear picture here. So first we have created a new object called string object called str that contains the content called coding. In the next step, we are changing that is to coding with sam. So here this is not modified. Okay, we are creating again a brand new object called coding with sam that contains the text coding with sam. So here what is happening, this str has become coding with sam object, and this the original which was there created first, that was sent to garbage collection in Java. So this is how the strings are handled in Java. So the bottleneck. So what is the problem with this? Okay, as we know, everything comes with its own set of baggage of liabilities. Okay, let us see what is the liability of string being immutable. Okay, now consider building a long string by repeatedly attending characters or substrings in a loop. So what happens? Okay, so you are building a long string by repeatedly appending characters or substrings in a loop. Let us say we are creating some s is equal to s plus x. We are adding, go on adding and adding some literals to our original creating string. Okay, here each use of the plus operator in concatenation results in the creation of new intermediate string object. You can see the image here. First we have created an object a, then we added x to it, then we added another x to it, then we added another x to it. So what is happening here, with every addition of the character a new object is created during the runtime also. Okay, so result is equal to result plus another string. This is also going on for a repeated number of loops. So what happens when it is the case? In a loop with many iterations, this leads to the creation of large number of temporary objects. Obviously they are temporary because once it is changed, it is going to go for garbage collection. This is costly in terms of both CPU time. The CPU cycles means we are always creating a new object, not modifying the existing one. We are creating a new object. That means number of CPU cycles are increasing. We are going on creating objects and creating objects. And the memory is also utilized more, because every time you create a new object, old object has to be collected by the garbage collection, which is again a usage of memory is there. The alteration of the memory will be there. Okay, so what if we need a string that can be modified directly in place without creating a new object for every change? So how can we overcome this problem? How can we reduce the overhead of creating new objects? So that is answered using two things. The first one, which was introduced in JDK 1.0, is the string buffer. Okay, so let us see. When you create a string object, you are creating string that cannot be changed. This is once a string object has been created, you cannot change the characters. Each time you need an alternate version of the existing string, a new string is created that contains the modifications. Okay, so the original string is left unchanged. For those cases in which modified string is desired, so when we are starting to write a program, we know that we have to modify the string. In the beforehand, if we know that we are going to modify the string, the best way is to use either of these things, either a string buffer or a string builder. We are having the two options. Let us check one by one what these options are. Okay, so the first solution is a string buffer, the thread safe workhorse. Okay, the thread safe. This is one of the important thing. Let us see what that is. Okay, string buffer represents a growable and writable character sequence. It is designed for situations where a string needs to be modified after it is created. That means we know beforehand, before creating a string, we know that we are going to modify the string. So in that case, we are going to use the string buffer representation. So what are the features of this string buffer? Let us see. First one, it is mutable. That means characters and substrings can be inserted, appended, or deleted in place. We can make all the modifications possibly we can do to a string. The next one is growable. Okay, the string size is not fixed. Okay, it is can be increased. Okay, so it automatically allocates more memory as needed to accommodate the additions. And the third and the most important one, which differentiates it from StringBuilder, is synchronized. What is synchronization? As you all are aware, Java supports multi-threading. That means a bigger task is divided into smaller threads, multiple threads, and all these threads are executed consequently, and the result is again added to provide the solution to the original problem. That is multi-threading. That means splitting of a bigger problem into smaller number of threads and executing different threads individually. Okay, so it is suitable in the multi-threaded environments where multiple threads might modify the same string. Okay, in that such cases, string buffer is very helpful. So what is the important things we have to keep in mind while using the string buffer? We have to have differentiate between the length and capacity. Okay, so in the previous thing we have learned it is mutable, that is answered, and this is growable. So how can we make something growable? The answer for this is your capacity. So what we are doing to reduce the number of costly relocations, that means when you are going to add something to a string, obviously you mean you are adding some more memory. So every time when you are modifying, instead of gathering the memory, what we are doing, when we are creating the string itself using string buffer, we are allocating some additional memory to more than the components or the characters present in the string. Okay, for example, let us say we are having a string, that is string buffer SB. The object is SB, that is going to store hello. Okay, so hello, as we can see, that is 5 characters. Okay, so when we are creating this string using string buffer, keep concentration here, not string, simple string, it is a string buffer we are using here. So when we are using the string buffer and creating an object using the new keyword string buffer hello, so what we are creating, we are actually creating a string that contains hello as well as some pre-allocated space. So how much is this pre-allocated space? This pre-allocated space will be of 21 capacity. Okay, so that will be 16 characters more than the original one. So we are going to add the size of the memory of 16 characters to the original string. So suppose you are using some called red, then that means that is going to have you 13 plus 16 is equal to 19 capacity. Okay, so something you are having JNTU, that is your 4 letters. Okay, so for that we are having 4 plus 16 is equal to 20. So we are going to allocate 20 bytes of memory that is required. Okay, so we are so what we are having, a constructor initialized with a string reserves room for the string's length plus 16 additional characters. So here length gives you the number of characters present in the string, whereas capacity returns you the size of the memory allocated. Okay, these are the two important methods in your string buffer class. So to read write toolkit, modifying a string buffer in place, how we are going to modify, let us see here. Unlike string methods, this method modify the string buffer object directly and return a reference to the same object, allowing for method chaining. Here no new object is created. It is going to give you reference to the same object. Okay, so see here, key modification methods what we are having, let us see. First one is append. Append means concatenating the string representation of any data type to the end. Okay, we are adding any data type to it. Next, insert, index comma data. At a specific position you can insert data. Okay, you give the index first, what is the location you want to index, and you give the data. Okay, next delete. int start and int end. That gives you two locations where you can either start and end, and you can select the sequence of characters between them and you can delete them. Delete charAt, you can delete a single character at a given index. Replace, you can give start and end of a string and you can edit that string, replace that string with the given string. Next you have the reverse the order of characters. Suppose you are giving some Reddy, so reverse you can get YDAER. So that is how these things are going to work. If you see the example here, string buffer SB is equal to new string buffer A is equal to is given. Then we have appended it with 42 and exclamation mark. So what is the new value we are having? We are having A is equal to 42 exclamation mark. This is our new content in our string. So here we are not creating different SB objects. We have created only one SB object that is created using the new, and we are changing the contents twice. So this is how actually the string buffer works. So the next and the most important thing is, after string buffer we got something called string builder. Okay, so string builder is used when there are no multi-threading problems. Okay, when we are having a single thread or a single function to execute, the best way is use the string builder. Okay, so the only thing that is making it high performance than string buffer is, in string buffer, since it supports multi-threading, synchronization is must. So here string builder is not having the overhead of synchronizing. That is why it is fast. Okay, just like the TCP and UDP protocols which are present in our computer networks, one is fast because it doesn't have the overhead of having the acknowledgement of whether the packet is received or not. The same case we are having here. Okay, so the string builder is a direct replacement for string buffer. See, string buffer is synchronized, thread safe and slower, whereas string builder is not synchronized, so not thread safe, so it is faster. Okay, the one critical difference is string builder has the exact same API as string buffer. However, it is not synchronized. The benefit is the speed. The lack of synchronization overhead makes string builder significantly faster than string buffer. It is the preferred choice for all single threaded applications where a mutable string is required. If you are having only one string in the program and that has to be modified, the better way is use the string builder instead of string buffer. Okay, so at a glance, let us see the differences between the normal string class, string buffer and string builder. So first one, mutability. Obviously string is immutable, we cannot change anything. String buffer and string builder both are mutable. Thread safety, inherent safe, because it is safe because it cannot be changed. Okay, so here synchronized and thread safe, it is not synchronized and not thread safe. Performance is fast for access, slow for modifications. Why? Fast for access because it is an immutable string, so only the possible thing it is available. That's it. Only function it is having is it is available. Okay, so that makes it fast. But slow for modifications because whenever you modify, you are creating a new object which is obviously going to take more time. Next, slower due to synchronization and synchronization overhead. Here you can change the object, but you have to synchronize with the other threads. That is going to make it somewhat lagged. Fastest for modifications. It is not dependable on anything, so it is going to modify fast. It is introduced in JDK 1.0, the first version of the Java development kit, and it is introduced in the 5th iteration of the Java development kit. Primary uses fixed content strings, method parameters, and keys in mobs, where you want to use strings that are not going to change. For example, you are having a key value pair dictionary. So key and value are the headings which are not going to change, right? So for such cases, you are going to give the keys in a web. Suppose you are having a college website where the departments are fixed. You're not going to change the name of the department. So this can be given as string objects. Okay, string buffer, modifying strings in a multi-threaded environment and modifying singles in a single thread environment. Example, loops, string building, etc. Here we are going to use the string builder. So whenever you are writing a program that is going to use strings, that is your responsibility to identify what is your need. Okay, so if I need to modify the string content after creation? If the answer is no, a simple string will do your job. Okay, if your answer is yes, that means if you want to modify the strings content after creation, then again you are having two cases. What are those? Whether the string is accessed and modified by multiple threads simultaneously. Is it multi-threading is there in that? Then you have to go for string buffer. If no multi-threading, only single thread is there, then you have to go for the string builder. End of the day, it is completely responsibility of the programmer to identify his need and identify which kind of string he is going to create, either a string or a string buffer or a string builder. So that's it with our string in Java. Meet you in the next class. Thank you.